Have you ever wondered how the stars in our solar system came to be? In the cosmic beginnings, everything started from a simple, unassuming entity: the giant molecular clouds. These clouds, vast and cold, are the nurturing cradles of stars, composed primarily of hydrogen molecules with a sprinkle of dust and other elements. Our story of star formation begins when something, say a supernova explosion, triggers a disturbance in this cloud. This disturbance sets off a chain reaction, causing the cloud to collapse under its own gravity. As it collapses, fragments within the cloud begin to grow denser and hotter, forming what we call a protostar. Now here's where things get really interesting. As the protostar continues to contract and heat up, its core eventually reaches a temperature so high that hydrogen atoms begin to fuse together, releasing an enormous amount of energy. This process, known as nuclear fusion, marks the birth of a star. And that, cosmic voyagers, is how a star is born. From a simple cloud of gas and dust to a radiant celestial body. Now that we know how stars form, let's delve into what makes each star unique. Stars, those twinkling gems in the night sky, are as diverse as the cosmos themselves. They come in a variety of sizes, from tiny dwarfs that are barely a tenth the size of our sun, to supergiants that can be over 1,000 times larger. The size of a star is intimately tied to its lifespan, with smaller stars burning their fuel more slowly and thus living longer. The elements within a star also vary. Stars are born from clouds of gas and dust, primarily hydrogen and helium. Yet through the process of nuclear fusion, stars create heavier elements like carbon, nitrogen and oxygen. In their death throes, stars can even produce elements as heavy as gold and uranium. This process, known as stellar nucleosynthesis, is how all the elements heavier than helium in the universe are created. And what about brightness? Stars shine because of the energy they produce in their cores through nuclear fusion. But not all stars shine equally bright. The brightness of a star depends on two things: its size and its temperature. Larger, hotter stars shine more brightly than smaller, cooler ones. Speaking of temperature, this is what gives stars their color. Cooler stars emit light towards the red end of the spectrum, giving them a reddish appearance. On the other hand, hotter stars emit light towards the blue end of the spectrum, making them appear blue. Our sun, which is an average star, emits light across the entire spectrum, which is why it appears white to our eyes. Stars are also classified based on their characteristics into different types, or spectral classes. This classification, known as the Morgan-Keenan system, uses the letters O, B, A, F, G, K, and M, with O being the hottest and most massive stars, and M being the smallest and coolest. So the next time you look up at the night sky, remember, each star is as unique as a fingerprint. You may be wondering, how do these stars relate to our own solar system? Well, let's dive right in. Our solar system, home to Earth and 7 other planets, is tucked away in the outer arm of the Milky Way galaxy, a cosmic metropolis bustling with billions of stars. Now here's a fun fact. Our sun, that brilliant ball of light we see every day, is a star itself. It's a middle-aged one, about 4.5 billion years old, and it's the reason life on Earth exists. From its heat to the light it provides, the sun's characteristics shape our world in ways beyond comprehension. But the sun isn't the only star visible from Earth. On a clear night, you can see thousands of stars, each with their own stories and mysteries. Some are similar to our sun, while others are vastly different. Without our sun, our very own star, life as we know it would not exist. So the next time you look up at the night sky, remember, you're gazing at a sea of suns, each a cornerstone of its own solar system. Let's take a moment to voyage back through our stellar journey. We embarked on a cosmic trip, tracing the birth and evolution of stars, those radiant spheres of hot gas that light up our universe. We delved into their characteristics, unraveling the elements that form them and the weather conditions they endure. We even charted their position in our own solar system, highlighting their distance from our home planet Earth. We marveled at their unique specialties, pondered about the existence of dwarf stars, and compared the length of their days to ours. We examined their rotation speed and the time they take to orbit the sun. We even measured their dimensions, all in a bid to understand these celestial bodies better. And there you have it, Explorers of the Cosmos, a brief but illuminating journey through the stars in our solar system. Remember, the universe is vast and full of wonders, so keep your eyes to the skies and let your curiosity guide you. Join us again on our Universal Universe channel for more cosmic adventures, and don't forget to share this video with fellow stargazers. Until next time, keep exploring.